We're on lesson 30. Our objective says I will be able to graph functions. I'll be able to graph functions on a coordinate grid created from linear and nonlinear functions by substituting input values to determine output values. So the first thing we need to know is what is a linear equation. This word linear, it's going to come up a lot in this lesson. Linear just means something is a straight line. So a linear equation is an equation whose graph is a straight line. We talked about last time how if a relation was a function if it passed the vertical line test. We're going to talk about the vertical line test as well. So if something passes the vertical line test, it is a linear function. If it passes the vertical line test and it is a straight line, then you know it is a linear function. Okay, so the first thing says to graph each equation using a table of values. Use a graphing calculator, which we won't do for now. We also need to tell whether this represents a function and whether or not it is linear. So we have x values, we have y values. So the x values I'm always going to choose every single time are -2, -1, 0, 1, and 2. I'm always going to choose those values because it's going to include both positive and negative values. So I need to trace my x-axis and my y-axis. So here's x, here's y, okay? These values I picked, now I plug it back in. If x is equal to -2, what is y? Well, since x is equal to y, y is also -2. If x is -1, y is -1. Same thing here and here. I'm just plugging in those values. X is equal to y, so each x value is the exact same as each y value. Now all I have to do is graph them. To graph -2, 2, go left 2, down 2. Graph -1, 1, left 1, down 1. 0, 0 is the origin. 1, 1 is here. 2, 2 is here. Connect those points. That is the graph y equals x. Now we need to tell whether or not it is linear and whether or not it is a function. Well, it is linear because it's a straight line. If it's a straight line, it's linear. So this is a linear. Now we need to tell if it's a function. Does it pass the vertical line test? Well, yeah. Anytime I draw a straight line, it's going to intersect this function in exactly one place. So if it intersects it in exactly one place, you know it is a function. So this is a linear function. All right, this is a linear function. 2. Remember, it is a function if it intercepts the equation or the function the relation, the graph in exactly one place. If it intercepts it in exactly one place, you know it's a function. So here, still have x values, still have y values. I'm still picking -2, -1, 0, 1, 2. Still picking those same values. Now, if I plug these in, if I plug in -2, I got to square -2 because I'm plugging it in for x. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. Okay? So all I'm doing is plugging those values into that function. Now I just need to graph it. -2, 4, I go left 2, up 4. Oh, did I go up 5? 1, 2, 3, 4. Oops, I went up 5 instead. So -2, 4. -1, 1, go left 1, up 1. 0, 0, that's the origin. 1, 1, that's here. 2, 4, that's here. Okay? Now all I have to do is connect those points. Make sure you get all of those points connected. Now I need to tell whether or not this is a linear function or a nonlinear function. So first I need to see, does it pass the vertical line test? Anytime I draw a vertical line, it's going to intercept this function in exactly one place. If it intercepts it in exactly one place, you know it is a function. So it is a function, but is it linear? No, this graph is not a straight line. It's more of a U shape. So this is a non-linear function. Remember, it's linear if it's a straight line. It's a function if it passes the vertical line test. So this is a non-linear function. Here what we're doing is we are matching graphs to tables. Matching graphs to tables. So what I see is, I see a lot of tables of values, and I see some graphs. I just need to find which table matches which graph. Well, I see table 1. Table 1, I see this point 0, 4. The only graph out of these three that has the point 0, 4 is right here. So I know that table 1 matches graph 3. So I've got that here. Graph 3 matches table 1. Table 2, I see this point 0, negative 1. The only one that has the point 0, negative 1 is right here, graph 1. There's that point right there, 0, negative 1. So I know that table 2 matches to graph 1. And then graph 2, I'm looking for a point in graph 2. I see this point right, or no, let's stay with tables. We were looking at the tables. Table 3 is the point 0, 2. I see the point 0, 2. The only one that has the point 0, 2 is right here. So graph 2 matches to table 3. Graph 2 matches table 3. I'm basically just picking the x coordinates and the y coordinates and figuring out which one is matched to which graph. In example 3, I'm matching the equations to the graphs. I'm matching these equations to the graphs. Equation A, if I'm trying to figure out which one is which, this is x plus 3. So I'm not sure which one of these graphs this is, but what I could do to figure it out is find some x values, just like I did before, and figure out, okay, if I plug in those x values, what am I going to get out for a y value? So let's say I plug in the point 0 into this equation. 0 plus 3 would give me 3, so that would be the point 0, 3. My x value would be 0, my y value would be 3. A graph that has that point would be this one right here. That has the point 0, 3. I would need to pick another point just to make sure. If I plugged in 1, 1 plus 3 would give me 4, so that would be the point 1, 4. Which one has the point 1, 4? This one right here does. If I continued to plug in points, I would have 2, 5, which would also be right here on this line, the point 2, 5. Okay? So I'm plugging in points and I'm seeing every single time I'm getting these ordered pairs which are matched by this graph. Now here in equation B, so what we see is that equation A matches graph 2. Equation A matches graph 2. Equation B, we see that it has an absolute value bracket. So I remember that the absolute value is a positive. Absolute value will always be a positive. So even if I plug in a negative x value, I'm always going to get a positive y value here, because this is always going to end up positive. So I need something that has just positive y values. Just positive y values. So I see that this one, we look at the y values, these down here are our y values. Okay? These are our negative y values. In this section, this would include the negative y values. So I see that this includes negative y values, so we know it's not that, but it could be this one or this one. It could be graph 3 and graph 1. What I see is that graph 1 only has positive x values, because graph 2 has some negative x values over here. These are all of my negatives for x. So I need to figure out which graph only has positive x values. Well, the absolute value we know is positive, so the y values would always be positive here. But in equation C, we're trying to figure out, okay, can you have a negative x value in C? Well, the square root of a number, you cannot have the square root of a negative number, so the x value here could never be negative. The x value could never be negative, so I need a graph that has no negative x values. That's going to be this graph right here. This graph has no negative x values, so that means that equation B matches graph 3 and equation C matches graph 1. Because the square root of a number cannot be negative. Square root can never be negative, so the only one that has no negative x values is graph 1. Okay? The x values here are not, the negative x values are not included in the graph. All of these x values are positive, so equation C matches graph 1, and equation B is here, matches graph 2. Okay? It can include negative x values because you can plug in a negative x value, but you're always going to get out a positive y value. All right, the last thing says to use the graphs to identify the domain and range of each function. So here's a graph. The domain, we remember, is the x value. So I'm figuring out what are all the what are all the possible x values. So the way that we can write this is like this. Domain, or D, equals. What are the possible x values? Well, it looks like the x values can be anything greater than 0, because all these numbers are positive. All the x values are positive. It can be anything that's greater than 0, so my domain or my x values are greater than 0. Remember, the range are the y values. I see that the y values must be greater than, the y values start here and they keep going up, 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 so the y values must be greater than or equal to 1. So the range is y. Remember, domain is x and range is y. This graph shows only x values that are greater than 0 because we start right here and all these x values are greater than 0, and then the range values are greater than 1. So the domain x is greater than 0, the range y is greater than or equal to 1, because x could equal 0, x equals 0 right here, and y could equal 1, y equals 1 right there. Okay, we're going to skip the last one and that will be all.